Then finally, this part is a lot of calculation based on F equals to MA. So it's more questions. So we will do another set question 7, then we will take a break. Maybe you want to do a sketch. And whatever you revised earlier is gonna be helpful here.
How to do.
Okay, so we draw the situation. So we draw a box on the ground. So Peter pushes a box with a force 8 newtons. So the applied force is 8 newtons. Then the question says that there is a frictional force acting on the box. And earlier on, I said friction is opposing the motion. So if the object is going in the
It's
forward
also
direction,
it's
so it
also because it's a constant speed.
yeah, it's a constant speed, it's not hindering anything. So friction is here, then it's moving at constant speed, so it's moving in the direction of the applied force. Constant velocity equals to acceleration equals to 0. See something there? So then resultant force equals to mass times acceleration. Then resultant force, what is the resultant force here? Based on the arrows.
0
Then how do you find? You use 8 newtons minus the friction, right? And it will give you
minus
0.
equals 0.
So friction equals to 8 newtons. See what happened there?
Yeah.
8 newtons. Then you have that same carton. Well, I see a typo there. This one is 1.25 meter per second square. Full stop. It's a typo. So drawing again. Let's see. What's your answer? F minus. So your drawing would be, let me use this. So your drawing here, she applies on force. This thing is 2.5 kg. So mass must be in kilograms. Remember that. Then mass, okay. Then acceleration is 1.25. Okay, then if the frictional force acting here, so I overlap your drawing of your friction and label 2.4 here. Okay, then there's applied force on top this. So F minus 2.4 equals to 2.5 times 1.25 this. So this line is okay, 2.5 times 1.25 plus 2.4. How do you get this answer?
2.5 times 1.25 over 2.4.
Why over 2.4? It's like that. So you bring over should be a plus, right? Okay.
5.525.
Yeah, so you have a rocket now here, mass 400 kilograms. Then there's an upward force here, and it runs on a weight of 4,000 newtons. Then we are required to find the acceleration. So it's your take on this. Then we will go through it if we have to. Units, acceleration is in newtons. You want to reconsider? Okay, wait. I think this one has a problem. So this is 6500 minus 4,000 equals to 400 times 8. Let me calculate. I didn't change the answer. 6500 minus 400 divided by 400. Yep, it's 6.25. Acceleration is 6.25 meter per second square. Your answer is correct. This is next one. Car is accelerating at 5 meters per second squared. If the forward force produced by the engine is 4,500 and the frictional force acting on the car is 1,500, calculate the mass of the car. We would draw, it's easier. So we have the car, it accelerates at 5 meters per second squared. Okay, then there's a forward force of 4,500 newtons. Friction going in the reverse is 1,500. Then the question say calculate the mass of the car. So correct, first line. So 4,500 minus this times 5. Meter per second square units. Oh, sorry, this is M. So this A, right, is not A, this is M equals to 600. Then, so because it's M, right, then it's kilograms. You use the wrong symbol up there. Right, you use the wrong symbol there because your A is already here. Okay, anything else is fine. So another one. This may be a two-step question. So then you have to, the force is, I don't know. Okay, look at your first diagram here. Is it possible that it moves like a constant velocity with the current, whatever you have in your diagram? Is there another force in the system?
Not sure.
Okay, so you like acceleration is zero because okay, the acceleration is zero because you have constant velocity. Then currently you only have one force. For acceleration to be zero, that means the resultant force must be zero. That means mass times acceleration equals to zero. Then, but there is a force here, so your resultant force can not be zero. So in that case, there must be another force, maybe friction here. Then the surface is the same. That means friction will be the same. So that means in your second scenario, where you push this and then you have acceleration of 0.75, right? That means there's another friction here, which is the same value from here. So which means you have to first find the friction on the floor or the friction between the box and the floor from your first diagram. Then use the friction from the first diagram, put it here, then using this again to find out the applied force is how much. So you try first, then we continue. 15 Newton. In the first diagram, the force is 15 Newton. So, uh, so then you found your friction to be 15 newtons. So then you bring this 15 newtons here. So this is first part, okay. Then your ultimate aim is to find this one. Distance, acceleration. 4 times 3.75 plus 5 minutes. So we have a speed time graph for 800 kilogram car. So then the car first accelerates to 80 kilometers per hour on a dry road. And then it maintains this speed for 10 seconds before brakes are applied at 20 seconds. Calculate the resultant force acting on this from 0 to 10 seconds. So they are looking for resultant force here. Then if it's resultant force, you will need the mass and then the acceleration. Okay, acceleration is 8. Yes, next, that is, you're on the right track. Let's do units. Okay, let's see. Do I have a wrong bad answer again? So, units, okay, 8 is on the right track. And then what is the units?
Meters per second square.
Look over here and look over here. So,
km per second square.
Uh, first of all, right, if it's in kilometers per hour here, then your time has to be in hours before you can have km per hour square. But what happened to you is you use km per hour minus km per hour because 0 is also kilometers per hour. Then 10, right? 10 is in second. So the calculation itself has the problem because of your units. But the idea of finding acceleration is correct.
0.002777777.
How do you get that? How do you get that?
10 divided by 60 divided by 60.
Then, okay, so then after that, you convert everything to kilometers per hour, per square hour, right? Then what about your force? Force is in newtons when this is in kilograms and this is in meters per second. Will there be a problem after you take your acceleration from here and plug it over the side? So what you can do is to, from the start, just convert 80 kilometers per hour to meter per second. You save a lot of trouble after that if you do that as a very first step. Okay, how do we get 22.2? Let me
80 km per hour to meters per second.
okay, let's do a brief one there. So 80 km over an hour, then it will be 80 times 1,000 divided by 3,600 seconds. Did you do this?
Yeah.
So let's just do this to confirm that our answer is correct. And this is also done. This step is written down here because in case you want to rewatch this video, then at least you know what happened back then, which is now. So this is correct. So 22 so this 22 meter per second minus of 0 divided by 10 seconds. So this is your acceleration equals to yeah, meters per second squared. Then you would do F equals to MA. So why you keep getting exclamation mark right here? So MA mass is 800. That one is, yeah. So this step is correct already. So 800 times 2.22, right? Okay. So watch out for your units. Then this is the second part. Calculate the resultant force acting on the car from 10 seconds to 20 seconds, which is here. Why is 0?
Because that a constant.
So right, if this is a structured question, first you have to say that acceleration equals to 0 meters per second squared. It's a structured question right now, so you have to write this. So resultant force equals to mass times acceleration equals to 800 times 0 equals to 0 newtons. You have a presentation issue. Okay, your answer is correct lah. And down here, because it's acceleration equals to 0, that's correct lah. But you have to tell whoever who is reading your answer, your thinking. Okay.
Yeah.
Part B. So you're supposed to calculate the braking force from 20 to 25. Okay, so let's see. Acceleration is uh do you make the same mistake again? Units, check the units. You caught my hint there. Did you get my hint? We calculated this just now. You want to change your answer?
Changed already. Yeah.
Hmm? This
Changed
one,
2.22.
acceleration would be final minus initial over 5 seconds. So it's negative 4.44 meter per second squared. Calculate the braking force. So then the deceleration is that much. So then it will be 800 times 4.44, I think. You see? Your this one is gone because of this one. You know what I'm saying?
Yes.
So now the car has some passenger. So mass is 9600. Oh, sorry, 960 kilogram. Then after that, then the friction on top of it remains unchanged. Okay. Then you know F equals to MA. So the force remains unchanged. So just now from the first part, we have force as 1776 Newton. Can we find acceleration from here? Can find A for me? You do 1776 divided by 960. Yeah. So it's 1.85, right?
Yeah.
So then you want to find the time taken for the car to accelerate to 80 kilometers per hour from rest. That means I can draw a graph like that, and then it starts with 0, and then it hits 80 kilometers per hour from rest. Then this is 22.2. Then you find t. So the acceleration here is 1.85. Can you find t? No, acceleration is v minus u over t. What's the value for time? Acceleration is 1.85. Then your final speed is 22.2. Then initial speed starts from 0. So this is 0. 12 seconds. Right. Okay. Next one. So okay, back to this. So you still have that car with mass 960. Okay. Then they stop on a wet road with only half the braking force. So now the force is, don't know how much. The braking force was, let's check the part B. Braking force was 3552. Okay. Braking force is 3552 newtons. So half the braking force is, what is that?
Numbers appearing at 20 seconds.
Yes. So now calculate the distance traveled after the brakes has been applied. So previous part, we know that time taken to accelerate from 80 to rest is 12. Then the brake starts at 20. Then acceleration was 1.85. The resultant force in the distance traveled by the brakes. So you have to find how long it takes to go to 0. So how do I come to conclusion that what is this deceleration down here? In order to find, okay, so this is a VT graph. This is a VT graph. In order to find the distance traveled, that means you want to find the area of the graph, area under the graph.
Area under graph.
So then our question here is, right, because now the situation is different and it doesn't stop at 25 anymore. So there is a time taken for the car to come to a stop. Then there will be a different deceleration here. So how do we find t? Because distance will be half times base times height. That means half times t times 22.2. Because we were given a clue here, the force is half, braking force is half of 3552. Then we know this.
Half of 3552 is 1776.
So this is 1776. So the braking force is 1776. So here again, 1776 equals to 960 times 8. So the braking force is, the acceleration is how much? Or deceleration is how much?
1.8.
Okay, so the deceleration is 1.85. So that means the gradient here is negative 1.85. Can you find t?
22.1. 22.1.
22.1. So t is 22.1. Acceleration is final minus initial over time. So acceleration is minus 1.85. Then final speed is 0. Initial is negative. Initial is 22.2. Then what is the time? Negative 22.2 over t. T will be negative 22.2 divided by negative 1.85. T is 12 also. So that means it takes 12 seconds. It takes 12. Then your distance?
22.2.
Distance will be half times 12, half times base times height, like that, right?
133.2.
Okay. So 133.2. So if you run to 3SF, that'll be 133. Okay, that's all. So you have a 9A, down here you have a mass of 5 kilograms, and then it's resting on the horizontal surface. So you have a force which steadily increases from 0 and is applied at X here in the direction shown. Then the mass eventually start to move. Then it say explain what prevents the mass from moving until F reaches a certain magnitude. Make a wild guess. Okay, friction. Anything else? Okay, later you will see something like this. What happens is, right, when an object is stationary, there's friction here. When it's stationary, there's a friction here. So if friction is correct, then what about friction? Because now down here, there's an explanation. So what should you say? We have to explain. No. So what happens is like this. You have friction here, friction F, okay? Then you have a force that is applied. So let's say friction is 10 newtons. So if the force is 1 Newton applied, will the object move? No. Okay. So
the force is bigger than the applied force.
yeah, so it doesn't move, right?
Yeah.
So then it turns into 2 newtons. Will it move?
No.
Okay. Then if it's 5 newtons, will it move?
No.
Okay. So it eventually so it's a force increasing, right? Increasing force is applied down here. So now 10 newton, will it move?
No. Because the forces on each side are equal.
Okay. So 10.1, will it move?
Yeah.
So how are you gonna how will you put this into words? This explanation is not correct. So how do you put this, whatever we just discussed, into words?
The applied force is increasing.
Okay.
So that the mass of 5 kg can move.
Now it's explaining why it is not moving until it reaches a certain magnitude. So you can say the applied,
frictional force is bigger than the applied force.
yeah, so the applied force is lesser than the friction present that is present. Okay, the applied force is lesser than the friction present here, number one. So then the object only moves when the applied force is greater than the friction present. Okay, then the object will start moving. So explain what prevents the mass from moving. So it's these 2 points here, which is what you say lah, which is what you get from this diagram. Okay, Ken?
Yeah.
Okay, so there's this, and I think you have the file already. Okay, next one. So now the mass is moving at a steady speed of 0.4 when the applied force is 15 newtons. Okay, then draw the other horizontal force that is acting on this mass.
What is FP?
The force that you're going to draw. This object is moving at a constant speed. Okay, so what is the value of FP? What is the value of FP? Why is it 15?
Because it's moving at a constant speed.
Okay, now there's a force. The force is increased to 20 newtons and acts on it for 0.5 seconds. What is the acceleration? Yeah, friction is still 15. Yes. Find the acceleration. What's the unit? So you have this floor down here. You always forget your units. 6. So assuming all the forces, okay, assuming all forces remain unchanged. So that means we have a 15 here, and then we have a 20 here. Then time is 0.5 seconds. Then you are supposed to calculate the maximum speed. Acceleration is 1 meter per second squared. So if you have problem with finding the maximum speed, you can just draw a graph. So that means the speed starts from 0.4 this time out because it starts like this, right? Then it accelerates at 1 meter per second squared. So then this time goes on for 0.5 seconds. Then they ask for what is the maximum speed, like that. So it's like this. Then again, remember your formula A equals to V minus U over T. I hope this helps. What's the answer? You're not completed yet, right?
Minus 0.2.
Minus 0.2.
0.2.
Okay. So let me use the formula too. Okay, A is 1, then time is 0.5. Then final speed is question mark. Then U is 0.4. So A equals to V minus 0.4 over 0.5. So it's 1 times 0.5 equals to V minus 0.4. So it's V equals to 0.5 plus 0.4 equals to 0.9 meter per second. This line is correct. I think something happened after that. Okay? Okay, 0.9.